Welcome to Narayan Microwave Technologies.
This is the demo of DC, AC and wave shaping circuit trainer. In this board we have got DC supply 0 to 15 volt and 0 to 30 volt. Then we have sine waveform, square wave generator, these two as a function generator. Then we have two potentiometer, one is of 10 kilo ohm, another one is of 470 ohms. Then we have 1 kilo ohm resistors bank, total 4 numbers of resistor. Then we have capacitor of different values, diode bank, inductor 50 millihenry, 50 millihenry, the T networks. So these are the components mounted on a board. By using this board you can perform DC experiments, various experiments you can perform, such as Ohm's law, in Kirchhoff's law, maximum power transfer theorem, superposition theorem, Millman's theorem, etc. etc. And for a wave shaping circuit you can perform experiments like integrator, differentiator, clipping, clamping, etc. etc. So by using the single kit you can perform n number of experiments. In this kit let us experiment or let us perform 1 to 2 experiments. Here I have connected one simple experiment of Ohm's law. What connections I have done is I have used one this current meter in between the supply and the resistor. This resistor, the other part of the resistor goes to the ground terminal of power supply. That's it. Current meter is connected over here. This is our current meter and this is our voltage. Now let us increase the voltage and see the output on current meter. Suppose I have given 3 voltage, okay. Resistor value is 1 kilo ohm. So the current would be I is equal to V divided by R. So 3 voltage divided by 1 kilo ohm. So automatically your current would be 3 milliampere, which is observed over here. If you further increase the voltage 7 volt, your current would be automatically 7 milliampere. So this is your Ohm's law you can perform on this board. This is the connection for integrated circuit. It is a type of wave shaping circuit. The connection is such a way that the square wave, here the one square wave points are there, it is given to the resistor, the other terminal of resistor given to the capacitor, and the other terminal of capacitor given to the ground, and our output would be observed across the capacitor. So the second channel of DSO is connected to this terminal and first channel connected to the input circuitry. Here you can observe at the waveform, at the oscilloscope, square wave is our input and triangular shape is our integrated output. If you change the frequency of square wave, you can check the shape of integrated circuit. So this is your integrated circuit over here. Here I have used 100 microfarad capacitor. So instead of 100 microfarad, you can change to 1 microfarad or 0.1 microfarad and you can observe the effect on the output waveform. Suppose I am changing it from 100 microfarad to 1 microfarad and I am connecting the second channel across this capacitor, see, you can check over here, the shape of our integrator output is changed. Again I am increasing the frequency. See, this is the output of your integrator, while the value of R and C is 1 kilo ohm and 1 microfarad respectively. So you can calculate the RC, that is time constant. R multiplied by C is your time constant. So when you change the value of R, either R or C, so the wave shape of your integrated output will be changed. So this is your integrator. Similarly, you can do the experiment of differentiator. For differentiator, see, for integrator I have given the square wave to resistor, and across capacitor I am taking the output. But for integrator it is quite reverse. For integrator I will give to the circuit, to the capacitor, and I will check the output across the resistor. Other terminal of capacitor given to the resistor, and the other terminal of resistor given to the ground. Here I am having the differentiator output. Here you will be having you can see the effect of different values. Since I have used the 1 microfarad, so instead of 1 microfarad you can change to 100 microfarad, and you can observe the waveform. Okay, so on this terminal you can observe the differentiator circuit, or you can just simply change the frequency and observe the waveform on oscilloscope. Here we have 1 kilo ohm. Each value of resistors is same, but here the value of resistors, here the value of capacitors are different. So instead of 1 microfarad you can change to 100 microfarad, like we have done it in integrator, or you can change to 0.1 microfarad, and you can observe the effect of differentiator on oscilloscope. So these 2 to 3 experiments I have shown in this video, but you can do many experiments. Like I have said earlier, Millman's theorem can be performed, superposition can be performed, maximum transfer theorem can be performed. So various experiments can be performed by using the single kit. Thank you for watching the video.